So let's go ahead and calculate the linear approximation to the area of a square whose side is 2.01. So the function, I'm just going to call it a of x, where x is the side length of a square. Okay. Where x is the side length of the square. That's equal to the function is x squared, right? If you want the area, let me just draw out a picture of what's going on. This won't be perfect, but you'll get the idea. Okay, so here's our square. Each of the side lengths are x, and so the area is given by multiplying this guy by this guy, so x squared. So the graph of that guy looks something like this. Of course, we're only concerned with x values that are positive. So here's a of x, which equals x squared. Here's x. Here's the area. Now what we're asked to do is we're asked to approximate this guy. So what we're going to do is we're going to use an area that we know really well. If the side length was 2, so let me draw out a picture of that guy. Okay, so if the side lengths were 2, then we know that the area would be 4. Now what we want is, what about at 2.01? What is the area? That's what we're looking for. So we're going to get an approximation for that by throwing in a tangent line right here, like that. Okay. So let's do it. We'll do it algebraically here, and then I'll show you with the picture what's going on. So as we use this line to approximate, we want this height. We're going to use this point right here, this lower green one, to approximate the blue one. So it'll be an underestimate by a little bit. So how we do that is, first we have to find f prime at 2, because that gives us the slope of that green line. So f prime at 2, well, I put f in there, I should have put a. I need to be consistent with my notation here. Okay, so a prime at 2, well, a prime of x is equal to 2x. So a prime at 2 is 2 times 2, which is 4. So the slope here is 4. So what we need to do to figure out what this green length is right here, which we call dy, we know that dy is going to be equal to 4, which is a prime at 2, times the change in the x value, which is 4 times 0.01. That's this distance right here, which is 0.04. So this guy right here is a length of 0.04. It was already at a height of 4. So our green dot, our approximation, is equal to 4.04. So our best guess at this guy right here is 4.04, but we know it's not, because we know right here is 4.04. We missed the mark by that much. That's kind of our error amount. Now geometrically, here's what it looks like. What we've done by adding 0.04 is we've taken and we've extended each of these guys by 0.01. So this side length is 2.01. This side length is also 2.01. And if, I'm going to make this guy over here purple, I'll make these guys, I don't know, yellow. And so what we've done is this area, this yellow area right here is 2 times 0.1, so 0.02. This guy is 0.02. And if you add those guys together, that's your 0.04. So these two yellow, if you add them together, that's dy. That's the approximate change. That is our linear estimated change. Okay? What it missed to pick up is it missed this guy right here. And that guy right there is 0.01 times 0.01, which is 0.00, right? If I multiply these guys together, I get 1, and then I have to move the decimal place over 4 times. So 1, 2, whoops, I didn't move it over quite far enough, I believe. So let's just go ahead and check that. So 0.001. So this right here is the part, that's the purple part. Let me do it in purple here. This guy right here is 0.01, because it's this length, times this length, which equals 0.0001. So that's the piece that we missed. So if you look at the actual area at 2.01 is going to be equal to this area on the inside, which we already know is 4, plus my two pieces here, which are my dy, 0.02 plus 0.02, plus this guy right here, 0.0001. So the overall area is 4.0401. This right here should be what 2.01 squared is. And there it is. Okay? So what we missed out on was just this little piece. But you can tell that this, as these guys, which is our delta x, as that guy becomes small, this little purple piece up here becomes extremely small. And so again, we don't really have to concern ourselves with it, because this little purple piece on the graph over here, that's this length right here. So you get this tie in between this picture and this graph. So hopefully that kind of clears things up a little bit for you.